Hi, guys. This is Amos here, and with us is our guest, uh, Richard Maynard from New Hampshire. Hi, Richard. How's everything going?
Oh, great, Amos. How we doing this fine, lovely evening?
All right. So I was asked by a few people about energy, and it is a big issue, especially we progressives are concerned with the environment and Green New Deal and so forth. And so energy plays a huge role in that perspective. And I understand that you have had your share of work in that field. Can you mention it?
Yeah, I went to a vocational high school here in Massachusetts, actually, for electrical. And I did go to Wentworth Institute in Boston for electrical engineering, but I'm not claiming to be an expert or an engineer. Basically, I've worked as an electrician for damn near 50 plus years. So I'm coming at it from a concerned citizen with experience in the electrical industry. So probably I worked from residential to commercial to industrial, and then I started working on production, being the various plants that we have to generate electricity. And I was also a nuclear certified electrician, even though I was arrested hopping the fence at Seabrook with Clamshell Alliance. But I still passed security clearance because I was honest about my answers and concerns, and I still passed Homeland Security and everything that was required to work on a nuclear facility.
That's cool. So let's talk a little bit about the issues at hand. So we have basically what's wrong with fossil fuels. We know that fossil fuels are really creating emissions not only during the burning but also during the excavation. And a lot of people are getting sick in the sites where they're excavated and around the world from these byproducts or materials, for example, in the tar sand excavations and so forth. The other thing is that the release of large quantities of carbon dioxide, CO2, when you're burning oil and coal, is accelerating global climate change and ocean acidification because water absorbs the CO2, and so it acidifies the ocean, causes a lot of coral death, and it changes the whole ecosystem in the ocean as well. And
Yeah,
fun,
and
yeah,
that's one of our major food supplies as well.
absolutely.
Fish.
Right, and right now there's a projection that all seafood sources are going to go extinct by 2050. So that's a big issue of concern. That's of course not the only reason, but that's a big part of it.
Well,
Also, we
if we start at the point that we take 1.5 degrees change, and there's not a the scientific community is not in disagreement. I mean, the political community is, but the science community is not. And really, we got to take a look at it, whether we believe it's true or not. If we don't treat it as if it's true, the damage that would be done to us if it proves to be true. I
Yep.
mean, we gotta prepare for the worst case scenario. And one of the other things to understand is you have the very same people that were pushing cigarettes do not cause damage to your health. Those very same people are now the very same people that are pushing that climate science, this climate emergency is not true. So,
Right.
what you had was you had these people that were employed as public relations people, and they just changed their job from uh, promoting cigarettes as not being damaging to your health to climate science. And The fact is, we know for 40 years now that Exxon, Enron, they've been lying to us.
Yeah, and they knew it back 50, 40 years ago, or whatever. Their scientists have produced these graphs that are extremely in agreement with the current situation. They predicted it to the T, and yet they were selling a different story to everybody else. Now, there is a controversy about natural gas, which is, according to Biden, Biden sees it. I don't know if that's still the case, but running for the presidency, he was considering natural gas, which is methane. That's a nicer way to say methane. He was considering it a bridge fuel. And the problem with that is that it's not so much the burning of it, but the fact that when you release methane into the atmosphere, and that's always done as part of the management and excavation of the product, then it causes a lot of damage. In fact, it's considered 84 times more impactful than CO2 in a shorter amount of span, but nevertheless, 84 times more damaging to the atmosphere than is CO2.
So I guess from that point there, we got that. Whether it's true or not, we need to treat it as being true that this is what's going to take place. I mean, we do have the fires in Australia, the tropical rainforest, California, the storms increasing in intensity. But I tend to be somewhat of a decentralist, meaning that when we centralize our energy production, regardless of what technique what prime mover, how we're generating it, by making it large, if there is natural occurrences, a storm, it knocks out our grid, maintenance purposes, that doesn't include terrorism. By having everything large scale and located at one place, that increases the cost in protecting it, and it also increases the reliability of the grid, because it centralizes it, and then if there's anything that goes wrong with it, the consequences of us losing power are really large. Whereas if we have a diversity, not only in our population and people and representation, but in our energy supply as well, the less damage is caused by any one item having difficulty or one location. So, I mean, you gotta kind of like have a vision of what's out there and what do you envision our world. What do you want to see our world to be like? What energy supplies do you want to see as that we're reliant upon? So once you start developing that vision, where I can share with you my experience and why I think the way I do, that we can establish this communication, two-way communication, where we can get things accomplished. It's not about ideology. It's not one party over another. It's not partisan. It's what is the best for us as a people, as a United States citizen of New Hampshire, a citizen of the planet. What are the best things for us to pursue for the benefit of all of us?
Yeah, yet it's inseparable from politics because money is involved, and therefore that's something that affects everything. So it's a politicized issue for sure. The Trump administration has acted to remove as many regulations that were protecting pure water and air as they could, and now the Biden's administration is going to spend months trying to bring all of these things back. However, so let's progress with this. So basically, we know that fossil fuels fuels include oil, coal, natural gas, and the extraction not even we even didn't even mention the ecological toll of all of this being excavated and put into the wild and leaks and so forth. But those are all things that are creating immeasurable damage to the environment every time something happens. So
Yeah,
what?
so we talk about things like environmental justice, and how what tends to be true is the people that have the least amount of money, where these damaging technologies are used, tends to affect the least among us, whether you're black,
Oh yeah,
brown, Native
of
American,
course.
or just your income level's low. I mean, when we saw the wind farms going in off of Cape Cod in Massachusetts, that was not in my backyard. That's the vacation spot of the rich. I mean, you can have these things elsewhere, but not. Don't let it bother me.
Yeah, yeah. Yeah, that's that. Of course, that's a big issue in that aspect. So, and we know that Native American people are also very affected by that because it's affecting their very way of life, their connection to nature, and their reliance on nature, whether it be picking rice or fishing or whatever. And of course, that becomes a whole. Racial, ethnic issue as well. So, what are the we need? We know we need alternatives. So, what are the alternatives? So, the main ones we're familiar with now are nuclear, the wind turbines, solar panel, and ocean generated electricity from waves or even ocean streams. There's also geothermal. Is there anything else I'm missing?
Uh, Not that I picked off while you were saying it. But actually, I think the most important one you missed out of what you were saying was efficiency. I mean, the process of efficiency is the most cost-effective means of our reducing our energy needs. So
Hmm.
not only are you reducing the cost of the final product, is you're reducing the need of the final product.
Right.
So on the efficiency is for almost every dollar we spend, whether it be weatherization or having improved motors or generators in our air conditioner or our heat pumps, that this efficiency is the most cost effective means, and it reduces our need for power that we can pursue. So
Yeah.
that was out of everything, that's the most important thing out of the whole list.
Yeah. And Phil says reduce, recycle. That's right. Yeah, and we had a little segment here on the channel about a new car called the Aptera wingless flight, which is amazing in its ability to reduce the consumption, can get an amazing amount of mileage, and it's going to be on the market next year if everything goes right. So yes, that's definitely a huge part of it is reducing our consumption, of course. But it's, in terms of energy sources, these are the energy sources that we have, and they're those are numbers from New Hampshire, correct?
Yes, they are. Those were from the New Hampshire Science, Technology, and Energy Committee at the close of the year. And it was not specifically geared towards any one type. It was just discussing the available means of production of electricity out there. So there was people in disagreement about one over the other, but it was a clear presentation of the various energy technologies.
Okay, and so can you discuss their this graph they're finding here?
Okay, well, they didn't come to a finding. Like I said, it was a basic. We need to look at what is available out there. We need to know what our choices are to be able to make a good decision. So the more data we have, the the better we can make a good decision from that data. So if I present, when we're looking at trying to stay at 1.5 degrees preferably as opposed to 2 degrees. The two biggest steps that we can take, we discussed efficiency, but one of them is the cost of carbon. Not a carbon tax. What's being promoted is a carbon cashback. Because what happens is, as we discussed, that the mining, the production, the location of the facilities that cause negative health consequences to both the people that work on it and the people that live by it. These are some, what do they call that? That cost. It's slipping my teeth right now, but we have to pay for it. It doesn't matter. People's health's got to be paid for. The question is, do we spend the money to prevent the negative consequences to the people's health, or do we spend the money on their health care afterwards? And that's not including the fact that the people are going to be sick or in fact die. I mean, it'd be nice to avoid that part of the process. So externality costs is what they're noted as. So there's all these costs associated with fossil fuel that are not part of the cost of our energy. So the energy company's not paying for those costs. They're not paying for the people that are getting sick from it.
Of course.
Okay.
Yeah.
So it's not a true cost of the electrical. So the whole thing about a price on carbon is to try to factor in these costs to make it a more realistic model of competitiveness, of capitalism. What are the costs? And the costs are there, they're just hidden. So if we take those costs out and we start applying them to the energy itself, that over time, they want the carbon cashback. It starts off at about, I think it's $20 a ton thereabouts, and efficient. They're not seeing a payback really till it gets around 60 or 70 realistically, where it starts bringing down. So when we start factoring the costs that we don't see, then the other supplies, the production of energy, becomes less expensive and would be more apt to be pursued. So
Right.
One of the biggest things is they put in a price on carbon that has the biggest consequence on us being to protect our planet and our family. One of the next steps that I see, and this is what I think, is wind power, because the energy companies aren't going to support us putting solar panels on everybody's house, because we'd never have to buy power from them, right? But the offshore wind is a model that businesses get to realize profits and invest for their investments, and we get to supply our electricity at the same time. So it's kind of like we get to take care of both things. I mean, I'd probably rather see solar panels on everybody's house, but I'll be happy with getting most of our electricity from wind.
We'll cover, yeah, we'll get into wind, but first I wanted to just have like an overview, and it seems like in this perspective they're expecting the fossil fuels to go significantly down, but the natural gas to stay pretty much where it is, nuclear pretty much where it is, and only the renewables are taking the place of the fossil fuels by 2035. And this is in New Hampshire, and you said New Hampshire is more conservative when it comes to energy.
Yeah, we got this New England Ratepayers Association that actually the governor here is really closely tied to it, to the point that the New England Ratepayers Association is a lobbyist arm of the fossil fuel industry, and they actually use the governor's business address and his brother's address as their legal addresses. So it's not even a hidden relationship in that regards. It's rather visible. Well, when you take a look at that, right? So we in New Hampshire we only have one coal plant left. Right now, it's only staying online for 28 days or less. So it's what they call capacity. It's a it's there if it's needed, and it's.
Oh, I think we lost you. Something happened with the connection. Oh, we have you back.
Am I back?
Yeah, I think you froze for a second. I guess your internet connection got. Yeah.
Yeah, I just got a message across the screen that says your connection is unstable. So we only have one coal plant here, and it almost doesn't run. And the issue with nuclear is that, I mean, we have Seabrook Station, which was one of the safest plants ever built. In fact, it was the last plant built as well. And the problem why nuclear doesn't have a expansion on that chart is the time period, because you're talking 10 or more years from the point of bid, the work going out for bid to it being finally used. So it's, the time period is excess of 10 years, which is past what we have to do to be able to look at 2 degrees, never mind 1.5. So that's why the nuclear doesn't calculate in there. So the expansion that's taking place in New Hampshire has a lot to do with solar, and it has a lot to do with wind, and the missing component that really needs to be addressed is storage.
Exactly. Yeah.
It's one thing to produce power, but it's another thing to produce power when it's needed. Mm-hmm. So that's the big problem. And the technology in the storage has really been, all this technology has been happening quickly. Europe's on, in regards to wind power, they're already on the second phase of installation. So they've already done round 1. They've already decommissioned those plants, and they're into round 2 of the next thing. And they're including so many things in their long-term plan. One, they're tying a wind power grid, offshore grid, just like you have the grid on land. They're also exploring green hydrogen. So they're producing excess wind power, and how do they do that storage? Well, they're using battery technology. They're using hydrogen is up and coming because they're going to produce green hydrogen, and then they're going to use the fossil fuel pipelines for the distribution mechanism for the hydrogen. So on top of the hydrogen and the storage, what else do we have? The storage is the biggest thing. There's a company, Highview, out of England that's doing a liquid air storage. And I don't see you. Are we still got a connection?
Yes, I'm here.
Okay. So in regards to what's going on, liquid air is old technology. We've had medical gases for hospitals. We've had welding and industrial gases. And what they're doing is they're taking a cooling tower, which is old technology. This is nothing new. This is all existing technology. And they're compressing the air, and the main one's nitrogen. And they're compressing the nitrogen during high production of energy time, so it's cheap.
Yep.
And otherwise we wouldn't use that power, and they're turning it into liquid nitrogen, and they're storing it, and then they're evaporating the liquid nitrogen to run a generator.
Yeah, I think it's going to become clearer. We have a little video on it in a little bit, so we're getting to it. But I wanted to stress, so that basically the two main issues with renewable, to make renewables work, is solving the issue of the losses on the grid. If you have major sites that are producing the electricity in one part of the country and need to get the electricity over to the other side. And the other one is the duck curve energy storage. Is that correct?
Yeah, I mean, the duck curve we didn't discuss, but what it is California's kind of out ahead in some of these areas. And one of the things they experience the duck curve is you have all this power, especially from solar, being generated during the daytime. So they have to they're actually hitting zero or even negative numbers because there's too much power. There's no one to sell it to. There's nowhere to use it. So we got to do one of two things. We got to either store it, or we have to be able to send it to an area that doesn't have that power. Now that isn't happening at this point because there hasn't been a vision, a plan of how we put all these different things and technology together to have the end result that we want. So at night, we don't have the wind, but it's real in the solar. So we have to fall back on these other means because there isn't storage, and the costs go through the roof. I mean, you're talking $600-900 a kilowatt, whereas during the daytime they couldn't give the stuff away. So there really needs to be a means of being able to store that, or you have to generate electricity where and when it's needed. And if you can't do it where and when it's needed, you have to be able to store it for later use.
Right, and the reason they call it the duck shape, obviously, is the shape of the duck. It's actually changed more into a duck shape since 2012 as the production has improved, and so you're meeting much more of the demand during the day, and then at night that's where the problem arises. So that's what called us to do all these all the scientists doing these different solutions, like you mentioned, like the nitrogen and the green hydrogen. And here's one example of what you mentioned of the liquid air.
Did you running the video there?
Yep.
Oh, okay.
HiView's liquid air energy storage system consists of three main components. A charging device, which uses off-peak or excess electricity to power an industrial liquefier which produces liquid air. An energy store, where the liquid air is held in an insulated tank at low pressure. And a power recovery unit, where regasified liquid air is used to drive a turbine and generate electricity. Operating efficiency is enhanced by adding a thermal store and our proprietary cold store. These capture and store waste cold and heat from the process. Here's how it works. Air is first cleaned and dried, and then refrigerated through a series of compression and expansion stages until the air liquefies. This process is based on the Claude cycle, which is over 100 years old. The liquefied air is then stored in insulated tanks at low pressure. These tanks are readily available from the industrial gases industry, or at very large scale, the LNG sector. When power is required, liquid air is drawn from the tanks, pumped to high pressure, reheated and expanded. The resulting high-pressure gas is then used to drive expansion turbine generators. No fuel is burnt in the process, resulting in the exhaust producing clean, dry air. Waste cold from this stage is captured by the cold store. This is later recycled to enhance liquefaction efficiency. And in a similar way, heat generated from compression during recharge is captured by the thermal store. Some of the key benefits of HiView's LAES system are No geographical constraints, unlike pumped hydro or compressed air energy storage, for example. Low capital and operating costs, using long-established global equipment suppliers and installers. Long lifetime of over 30 years, with components available off the shelf with thousands of hours of proven operation in many applications. A small footprint and high energy density compared with other energy storage solutions, and no harmful emissions. The system is completely modular and scalable from around 5 megawatts to hundreds of megawatts in power and up to 12 or more hours in duration. It can be built either as a standalone system or co-located near other processes to maximize performance. Large-scale storage offers the opportunity to bank energy and time shift it to periods of peak demand or hold it in reserve. This is critical for intermittent renewable power such as wind or solar, or to move excess off-peak energy to times of peak demand. The Highview LAES configuration is uniquely customizable. For example, the technology can integrate industrial waste heat from peaker plants, or waste heat from industrial plants such as steel mills, or utilize waste coal from LNG terminals, all resulting in improved operating efficiency. And the future? Design work has already begun on Highview's new gigaplant, capable of producing an output of 200 megawatts with a capacity of 1.2 gigawatt hours. Highview, delivering tomorrow's storage with today's technology.
All right.
There's
So,
probably a couple points I want to make along with that.
hold on,
One-
Richard. You turned all green, so you're transparent. I know you're in a very green mood, but
Oh boy.
yeah. So you were saying, meanwhile.
It was pointed out to me by someone, and I haven't pursued it yet, was the ability to take and compress the carbon so we can do some sort of carbon storage at that point. And another thing I wanted to point out is I did mention the last coal plant in New England, which is Bow power plant here in New Hampshire, or Bow, New Hampshire, or Merrimack Station, as they call it. That plant's capability at full capacity, 400 megawatts. They are building a compressed air plant in Vermont as we speak. And that is a liquid air plant that is 400 megawatts. So that is exactly the capacity, the same as fossil fuel industry, a coal plant. So I'd just rather see the energy produced that way. One of the things about energy, though, is also what they call community power. There's about a dozen states in the country right now, and what it is the citizens of that city, town, county can join together, and they can be their own power supply company. And that way, it's not the state government, it's not the federal government, it's the citizens that are in control of their energy future, where it comes from and how it's being developed. And it's putting it right at the, it's capitalism at its best, where you got many people and the people are responsible for their electrical supply, where it comes from and how they invest that money. So those are the things that I'm spending a lot of my effort on here in New Hampshire, which is the price on carbon, community power, and the wind. And the wind is partially because the Gulf of Maine offshore wind, there's some of the numbers coming back as if we had the ability to bring that into the grid and to distribute it where it was needed, Gulf of Maine wind power is 10% of the total electrical needs of the country at this time. So, I mean, there's a lot of exciting things taking place.
Mm-hmm. Yeah, and but in terms of the storage, there's a lot of interesting ideas, and that is not just the problem is, of course, that batteries are not really a full solution because at the present time the battery technology, lithium ion, is just keeping a few hours time, and it's not a full solution. To store all this energy for a longer period of time. So they are working on flow batteries. There's companies like ESS, Premia or something like that, and others that are trying to develop batteries that are going to be longer term and maybe even solid state that are not liquid cell. That would answer the issue, but in the meantime, there is a good use for these chemical transformations, and people are becoming very ingenious and coming up with really cool solutions. So while you try to turn your camera back from green, I'm going to play this next video.
Currently, about 96% of the world's energy storage comes from one technology, pumped hydro. This system is pretty straightforward. When there's excess energy on the grid, it's used to pump water uphill to a high elevation reservoir. Then, when there's energy demand, the water is released, driving a turbine as it flows into a reservoir below. But this requires a lot of land, disrupts the environment, and can only function in very specific geographies. Energyvault, a gravity-based storage company founded in 2017, was inspired by the concept, but thinks it can offer more.
And so we wanted to look at solving the storage problem with something much more environmental, much more low cost, much more scalable, and something that could be brought to market very quickly.
Instead of moving water, Energyvault uses cranes and wires to move 35-ton bricks up and down, depending on energy needs, in a process that's automated with machine vision software.
We have a system tower crane that's utilizing excess solar or wind to drive motors and generators that lift and stack the bricks in a very specific sequence. Then when the power is needed from the grid, that same system will lower the bricks and discharge the electricity.
This system is sized for utility scale operation. The company says a standard installation could include 20 towers, providing a total of 350 megawatt hours of storage capacity, enough to power around 40,000 homes for 24 hours.
Some of our customers are looking at very large deployments of multiple systems so that they'll have that power on demand for weeks and months and whenever it's going to be required.
The company recently received $110 million in funding from SoftBank Vision Fund, and it's building out a test facility in Italy, as well as a plant for India's Tata Power Company. But some say the sheer size of the operation means it just can't be a replacement for chemical batteries.
Sounds very simple. However, the energy density on those systems are very low. And so that's where we believe chemical-based storage still has an advantage in terms of a footprint. You can't install a gravity-based system in the city, but you'd have to install it outside in the remote areas.
Yeah, human ingenuity. That's quite incredible what kind of things they're coming up with. And yeah, Venom, that's exactly what we're talking about. The storage issues are the key, and they're working on it. There's even some company that is working on developing batteries that would be in the duration of days or weeks. So it's quite incredible. We'll see where we get, but certainly there's space to go. I can see you now. All right. And so, and in addition to that, there's challenges in each of these technologies individually. Like, for example, the blades of turbines. Up to now, they were not able to recycle those because they're composite materials, so they were bearing those massive blades, which is not really ideal for the environment. But even that is now a thing of the past. There's already in the works waste that GE started recycling, and what they do is they grind it into cement, and it reduces the cement carbon footprint, cement production carbon footprint by 27%, which is nothing to scoff about. So a lot of stuff is being done at the current moment, and even where it comes to photovoltaic solar panels, up till now the issue was that they're very low efficiency. They barely scrape the 20%, but now they're talking about 6 junction cells that may still be too expensive to use in production, but nevertheless they're developing that technology of having layers. Junction is basically the layers of the panel. There's different bandwidths that are being absorbed by each layer, so they're basically reusing the light until they get a higher percentage. They, in lab at least, they achieved close to 50% efficiency, which is incredible for panels.
Yeah, you made me aware of that area. I had looked at the amount of energy to produce the silicone for the solar panels was an area of interest to me.
Yes.
And I actually worked on one of the largest silicone production plants back in 2007, 2008 in Moses Lake, Washington. It was a company, REI Solar, out of Norway. And the thing about that was we were in the Grand Coulee Dam, the Chief Joseph, the Bonneville Dam. I mean, the supply of energy was inexpensive. So sometimes, I mean, when you look at the efficiency and the item, you've got to take into real world effects. You know, we were saying how liquid air is not overly efficient. Well, it is when you had no other way to store that energy and it was of no use. So now, I mean, so it's like you got to look at a little bit more than just, you got to look at real world applications. And one of the other things you have to do is when you're discussing, regardless of what it is, efficiency, it's what they refer to as cradle to grave. So you got to start at the very beginning of the process and look at every step along the way. And what could be one company's waste is another company's raw materials. So when you track it all the way through, from its birth, its inception, all the way to its end, that's when you start getting a true picture of what's going on. And in many cases, the simple thing that you pointed out with the blades, I mean, cutting them up for concrete and asphalt, I mean, may not seem like the most efficient way to deal with it, but it's much better than just burying the damn things.
Right. Yeah, and of course it's the whole picture. Like, for example, you're talking about panels. It resolves the issue of transferring through the grid because it's at use location. But on the other hand, you have all this material that's now out there, and you have to figure out how to prevent toxicity and pollution by decommissioned panels down the line, and it's a whole thing. Everything plays a role. Everything has to be looked at. And Venom in chat mentioned what you described to me, one of the storage solutions where they were using mine shafts, where they were lowering and lifting weights to store energy there, right?
Yeah, basically, I mean, there was a couple technologies besides Highview. I mean, they use, an example is they use hydro as a battery, pump the water up to a location and then run it down. In other locations, they had existing mine shafts, so they were during, when there was a lot of energy available, pulling up a weight. And they're also using it for rail. There's a rail system, so instead of dropping a weight down a hole, they actually have a train that they have up on the top of the hill, and they run it down the hill.
That's crazy.
And
yeah.
They're having that run generated. So there's so many different, some places like I'm in New England, Mount Washington is the highest mountain, and it's a foothill compared to out west. So, not all these things apply to different parts.
Yeah.
The rail or the mines wouldn't exist here, whereas out west they would.
Exactly. But how does the saying go? Use what you have, and how and not what you have not, or something like that. I don't know.
Oh, you just started bringing the beginning of that song into my head. By the time we sign off, I'll remember it.
All right. So now we're into large scale. There's been works on large scale solar installations, and that reduces the overhead, of course, rather than having a million people installing on their own roofs and all the labor and everything that's involved. You do it on one location, and they've right now reached amazing numbers particularly in India. The biggest one is in India, 2,245 megawatts of power, which is unbelievable for solar. And in China also 1,500 megawatts, things that we haven't seen before. Those are large scale projects, very, very impressive ones. And also I wanted to touch on, there's a lot of people who are saying, well, we have to still use nuclear before we get to green solutions to renewables, because there's no reason to not use this powerful medium. But like you mentioned, the time to implement those plans from design to implementation is about 10 years, and by that time we're going to be hopefully over the crisis, on the other side of the worst part of the crisis, hopefully. But it's not going to help us before then.
And 10 years is giving it, that's with things working well.
And even if the powers in the nuclear facilities work as designed and don't leak and don't have any issues, there's a cost to the radioactive matter mining and processing, right?
Yeah, I'm not a supporter of nuclear power as one of the choices, but you know what I would like to see? We have no ability to store that material. We've been developing that material for decades. We have high-level waste. It would be so nice if we were to bring some sort of technology into existence that would use the waste rather than having to wait for the natural decay of that waste to take place. I mean, the half-lives of these items, plutonium, 500,000 years, and I think it's cesium at 30,000 years. I mean, it would be so much nicer if we were able to. It's there, it's causing damage. Let's use it so it's not as dangerous. So I'd really support that.
And that is another point. But you mentioned to me that there was human cost to the mining of these materials, right?
Yeah, when you took, one of the studies that was out there was the Hopi Indians down in the Four Corners, and that was a mining facility there. And we do the documentation, the medical studies, the damage that was done. It exists. There's a case study out there. You can go right online and look for it, and it's there. So it's not unknown.
Right. So even if we get everything working smoothly, we're still paying a price. Now, since you mentioned the storage issue, that brings me to carbon recycling, to uranium recycling, or radioactive waste material recycling. Basically, the normal way reactor operates is you mine, you extract refine the uranium, so it has more of active uranium in it. By like 4% of the uranium has to be an isotope of 235, I believe. And if the rest of it is 238 and non-active, so you want to have at least 4% of it, the active isotope, and then you just burn it and you waste everything else. You have to bury or discard the entire barrel of radioactive material, which includes mostly material that you've never used. Now, there is a way that you can basically reuse that, and that is it's called the closed fuel cycle. You have again, you put the uranium in, but here instead of having the uranium just wasted, you have some of the neutrons flying inside of the reactor and activating a change from the non-active uranium, the U-238, to 239, and then it decays to NP 239, and eventually to plutonium by losing protons, and basically you're turning the inactive uranium isotope of 238 into a plutonium, active plutonium fuel that can be used in those reactors as well. The downside to it is, of course, that the process is expensive, more expensive than otherwise. It separates pure plutonium in the process, which then can be stolen, and basically it's a security issue. But the pros that you get out of it is what you mentioned, the decay of these materials after you're done with them, after you discard with them, are 300 to 500 years instead of thousands of years. And if that looks good, this looks a little better because they have something called a breeder fuel cycle, and those are reactors that are a little more complicated. It is easier to do them with thorium, which is why people are talking about thorium reactors so much, but they can be done with uranium as well. And in this situation, you have the recycling plant is actually done within the process, within the facility, and you can reuse all of that inactive uranium isotope, and in this case, the decay of the resulting material, the spent fuel that you cast is 300 years. So you extend you can use that fuel supply that we already have in circulation to tens of thousands of years, and you reduce the decay to 300 years, which is just it would be come a long way if they did that. So this is currently kind of theoretical. They haven't really done everything in practice, but it looks good on paper.
Yeah, one of the issues we have with things like this is, like I said, Seabrook Station was the last nuclear plant to be built in the United States. And in businesses, supply chain, you need, in capitalism, you need people manufacturing the products, the materials to use in order to be able to build these plants. And there is no supply chain. Okay, we haven't built them. There's no supply chain. There's no competition on supplying the necessary products and materials. So from a business point of view, that's one of why the cost overruns and everything's happening, because if it exists, it's a monopoly and there's no competition, there's no supply chain. But as you point out here, these things exist, they're causing damage, and it's really a question that we have to address regardless of whether it's part of the necessary energy development for us to protect this planet and the people on it, to stay at the 1.5, 2 degrees difference. It's something that we're going to have to address.
And like you said, this doesn't help us in the short run, which is our crisis right now. So, yeah. And mentioning, if we're talking about the future and the more distant future, there have been also breakthroughs this year on fusion. And they were talking about they finally are at the stage of finishing a 30-year-old design of fusion reactor, which is going to supposed to run this year. And we'll see what happens. There's been all kinds of interesting developments in that. So that's something to just look ahead for, just as far as interesting energy sources are concerned. And
yeah, I mean, one of the exciting things is to be able to have these choices. To be able to look at them and look at them dispassionately into what they're going to accomplish and do.
Yeah. And you mentioned also, before we wrap up, you mentioned this climate En-ROADS climate simulator application. Do you want to talk about that?
Yeah, I mean I'm retired, disabled right now, and I produce a local television show, and a large part of it has to do about energy and environment in New Hampshire and somewhat of the New England area when we touch base. And a lot of the trainings I've received in looking at energy and climate has that MIT product, which is a energy environment simulation tool. And the nice thing about that tool, I mean, we're at the point now in technology that we basically, your phone's almost a supercomputer of days past, And this is a product that you can take and run on your laptop or home computer and actually look at some of the effects of decisions. So it has many different tools that you can adjust, whether it be reforestation, nuclear power, electrification of our grid, efficiency technology, cost of carbon. It has the settings are set at where we are at today and what degree difference in temperature the result of these decisions have. So you're able to look at it yourself. And not only is this a good scientific tool, but it's a really good tool for sharing this talk we're having into real world where anybody out there can download it on their computer and take a look at it themselves.
Right. Okay. And do we have any other inputs or questions from the audience? Can type it now. Anything that you wanted to add, Richard? Anything in addition?
Well, I think we did a good introduction to the people and a lot of things that's going on. I think the biggest thing I can say is, as you pointed out with the nuclear, the same is proven too in all the energy fields. I mean, the amount of changes, the people, the schools, the colleges, the profitable companies, the nonprofits, the amount of energy and work and technology that's being that's happening right at this time just makes me so excited that it's not all doom and gloom. We can do this. It would really be nice that if we focused our energy as a world and treated it like it was a world war. I mean, this is a matter of our survival. And if we treated it that way, I'm very optimistic that we can do what's needed to get done.
But even if it wasn't treated that way, you made the point that this is like a imperative economically, that this is like just makes sense in terms of savings and profit alone.
Yeah. One of the things I was excited to see was I believe it was Ohio. I think it was Iowa or Ohio, one of those states. They had 5 active coal plants going. and it was a Republican state, and they closed 4 of those coal plants immediately and went to wind. They did not go to the step. It's all everybody's. The general school of thought was we go from coal, we go to gas, and then over time we get all these other things done. And actually they looked at the economics of it, and the economics were such was they closed the coal plants, they replaced 4 out of the 5 plants with wind, and the only reason they didn't close the last plant was because it wasn't located, the available wind was not where they could get it from production to its end use to the people that needed it. So they gave that plant in a 3-year time period to develop not only the wind power, but the ability to get that power to the people that needed it, to develop the grid. So that was a Republican, and they didn't care about the environment. Screw the environment. It was dollars and cents. It was the most profitable.
Yeah, exactly. So that's it. I hope that's gonna drive us into the future, and hopefully we make it in time before we melt. So thank you, Richard. Thanks for... I can't hear you for some reason. But...
I wasn't talking.
Oh, okay. Okay. Thank you very much for participating. This was great. And thank you guys for tuning in. We'll see you soon. See you on Saturday at 1 p.m. Eastern Time. We'll have No Joke again with our review of the week's politics. And it's going to be interesting.
Well, I thank you, everybody, for watching. Amos, thank you for giving me an opportunity to feel better about working towards getting this done.
Great. All right. Good night.
Take care. Good night, everybody.
Bye-bye. Okay, hold on. I'm gonna...
All right. A couple technical difficulties, but looks like we got past it.
Yes, I believe so. Let me make sure that we close all the connections here. I'm gonna run out on here.
No, I forgot to put my lights on. How was the lighting?
Lighting was fine. The lighting was okay. Yeah, lighting was fine.
Well, make sure I get a link and throw it in Facebook there. I'll probably take and throw it out into the Da Vinci and maybe do a little editing and clean it up a little bit for a finished product.
Yeah, you can definitely do that. I'm going to do that, but I usually do just the rough video edit on the channel through YouTube. YouTube has its own trim editor, so I do just a little bit of cleaning there.
Yeah, the nice thing about that editor is it leaves the show up. You know, if I take it off, it's not available till I put it back out in a finished product.
Right, and any views are not counted then. You have to reset the counter. Yep.
Yep. So, yeah, I just started doing that a little bit on, someone called me up on one of the finished shows, and I didn't want to start all over again. You know, I just wanted to fix that little one spot.